Hello everyone, this is the video lecture for pre-calculus. We're doing 4.4, solve for x. Okay, well it's called log equations, but we're going to solve for x, and that's what we're going to do. So, let's get right to it, honestly. There's nothing new. No new material, no new anything. You just do it. Um, so, here's our first one. Solve for x. I'm going to write it one more time, and that's pretty much it, okay? Solve for x every single time today. Okay, well, in this particular one, we want to get the same base on both sides. So I got 4 to the x is equal to 4 to the something. And I wonder what that number is going to be. So I'm thinking here, you can use a calculator, but I got 4, 16, 64. Yeah, I don't know if it's coming out exactly the way I wanted to. So that's kind of weird, right? what is that number that would make that work? Because I got 4 to the 1 is 4. 4 squared is 16. 4 cubed is 64. And then finally, I got 4 to the 4th is 256, actually. So it's like right there that I needed. It's in between these two guys. So yeah, how do I make that work? Um, well, it really is right between them. So if you wanted to, the answer is 3.5. By the way, hey, and that's just a funny little thing. 7/2, whatever you want to call it. Cool. But what I really want to do instead is start using our properties of logs to be able to do these things. So let's just do it the real way now. I have 4 to the x is equal to 128, and I want to solve for x. So you can do a couple different methods. I'm going to do friends from our last sections. So this is log base 4 of something equals something else. And so 4 and x were good friends no longer. You've exceeded my limits. Excuse yourself for my presence. And 128 is all by himself. Now he's got a friend with the 4. That is your answer. You're done here. But now, I don't think my math lab is going to accept this answer. Although it looks nice and pretty, it's just still like, okay, well, what's the number, right? We can go and do this change of base formula. So I've got log of 128 divided by log of 4. And if you go to your calculator, as in Desmo Scientific, and type that in, sure enough, 3.5 or 7/2. And that's your answer. So there's a couple ways to do this kind of problem, but really you are looking for the same base. It's just that this one turned out to be a little weird. And unfortunately, it's like one of your first questions, if not the first question. So I feel kind of like the very first question is like saying, hey, this is a pretty tough section, when it's not that tough, honestly. But we do have to look out for weird stuff. So here's another one. I want to get 2 on both sides. My goal is to say that this is 2 to some kind of power. Well, we can rewrite this a couple times. Like, for instance, it's a fraction. So that's going to be 8 to the negative 1. You can always make a fraction to a negative power. And that is 2 cubed makes an 8. Powers of powers multiply. So that's going to be a negative 3 now. And so that technically is going to be the way you rewrite it. Cancel your 2's out. 2 minus x is equal to negative 3. Solve for x. I'm going to add x to both sides to start with. And so we got 2 is equal to negative 3 plus x. Add 3 to both sides. And so x is equal to 5. Okay. Cool. That wasn't too bad. 4, 4, 15. So I've got 9. Doesn't look very good. It'll work. Okay. Because apparently I can't do any better. So to the power of x minus 2 over 4 is equal to the square root of 9. Well, I know that the square root of 9 is 3. So it's kind of silly that they didn't just put a 3 here. They're hinting at something here. They're saying, hey, it's not really supposed to be just a 3 because that would be too confusing for you. There's something behind it. So what's the power for a square root? It's actually a half. So we can cancel our 9's, and then we can just move about our business. So I need to solve for x. I'm going to multiply by the 4 to the other side. So we get a 2 now. add 2 to both sides, and x equals 4. Now, these are pretty simple answers, honestly, and that's good. Can you use Desmos graphing to help you with some of this? The answer is yes, kinda. You can do it on the homework, sure, but it's not designed for exams that way. Like, again, you can't do that on your exams. You can't use Desmos graphing, but you can use Desmos Scientific. And so I'm going to continue teaching this as if this were on the exam. And that's the way we should be doing it anyways. But again, just saying, there is other options, I understand, but we need to train ourselves in order to do the exams properly. All right, so 27 to something, and can I get a 27 out of that? And I don't think so. I mean, it's 27 squared and or cubed, and all of a sudden it's way bigger. So yeah, what they both have in common, though, is a 3. This is 3 cubed, all to the x plus 7. And this is 3 to the 4th, all to the x minus 5. Now remember that powers of powers multiply. I am going to cancel these 3 bases out, but it's 3 times x plus 7, and then 4 times the x minus 5. Distribute, so 3x plus 21, and then I got a 4x minus 20, and solve for x. So minus 3x on both sides. I feel like I'm writing really tiny today. Add 20 to both sides. And so this is actually just a single x, and that's a 41. So, well, there's your answer, I guess. Not too bad, not too bad. Okay, so that's all whenever you have the same base on both sides. But sometimes you cannot get that. You can't get the same base on both sides. And so let me rewrite. Oh, sorry, that's supposed to be an equal minus sign. Let me write this next problem. Oh my goodness, 13,000. Wow, that's pretty big. Anyways, solve for x. I don't think I'm going to write that again, okay? It's every time is solve for x. So, and that's supposed to be an 8. Come on. There we go. All right, cool. So we have our equation. Now I say, hey, I want to get the same base on both sides. And you're like, okay, well, I guess I can add to 5 first, right? I want to simplify it a little bit. So e to the power of 11x minus 3 is equal to now 11, nope, 13, 387. Okay. How do you get an e over here? You can't. You can't. So if you can't get the same base on both sides, the default response, I guess, is going to be ln both sides. ln both sides. It just so happens that ln is really nice for this problem in particular, but I choose ln just because that's kind of just part of the style, I guess. We just do it, and it works. So here we go. I'm going to ln both sides. I wanted to emphasize that's an ln, log natural. I've seen many students ask me, hey, I'm typing into my math lab, and it's not working. The IN, it's not working. And I'm like, it's not an I, it's an L. So, you know, it's a font thing, Times New Roman, Arial, that kind of thing. So I get it. It does look like an I. It surely does. But it makes no sense, right? It's logarithm, L, log natural. So make sure you're typing that correctly in my math lab. Anyways, cancel ln and e on both sides, because this is log base e, technically. I believe we saw that in the last section. So that's log base e. They cancel, and you're left with the x, or 11x minus 3 is equal to this ln over here. 13387. Okay, now this is where we're going to stop and pause for a second. I need to solve for x. I need to get this down to an exact answer, right? I'm not going to put this in the calculator and get a decimal yet. That's going to be part B of something like this. We still need to get an exact answer. So I need to move everything over. Like, my goal is x equals something, right? So I need to get x by itself. And these steps are very simple, but don't overcomplicate it. I have a plus 3 on both sides to start moving it over. Sure, totally agree. But here's the thing. it does not affect that number on the inside of a log. This number is staying put. In fact, sometimes I say, log natural, but I also say it's locked in. There you go. It's locked in where this number, this 13,000, will not change. So I think of it also kind of like a box, a lock box with a little locking key. And so you put $13,000 inside and then you lock it. So then I say, oh, hey, hold on. I had $3 I wanted to add in there, three little dollar bills. Can you go ahead and open it up? Nope, it's locked in. So that 3 is just going to have to sit on the outside. It will not go inside of the safe. It will not go inside the lockbox. Okay? Here, and then divide by 11 on both sides, right? Sure. That's totally fine. But there's nothing for you to do here. It's done. You can't divide any of these numbers by 11. That number's locked in. That wouldn't make sense because they don't really cancel. This is it. This is it. Literally, that's what you're typing into my math lab as an exact answer. This is your part A, the exact answer. Now, this particular question has a part B, approximate answer, and this is where you just type this into the calculator and you get a number, 1.13654. I don't know, round to whatever decimal places they say, but that's the idea here. Okay, cool. So ln both sides, ln both sides. Let's do some more just like this. So I got a 441. So 3 to the 2x plus 7 is equal to 5 to the x minus 2. And they say, hey, go ahead and solve for x. All right, well, this one, looking ahead on my notes here, this is crazy. But that's okay, it works. So can I get a 3 over here? Nope. Can I make a 5 over here? Nope. So I can't get the same base on both sides. I must then ln both sides. It's the default, hey, what do I do if I'm stuck? You ln both sides. And that's okay. That's all part of it here. Now, the reason why we're logging here is if you go back up, like ln and e, they cancel, and it made it really simple. Like, we just skipped ahead. This is just me talking about stuff. So it's really simple to go from there to there. Awesome. But here, I can't cancel. Instead, I'm just going to bring these down to the front. There's that power rule of logarithms. So I got all the stuff in the front, and then ln of 3. And then I got all this stuff here, ln of 5. Cool. Now, I'm using parentheses for this because it's a term. It's a whole entire, numerator, a whole factor, basically. And this ln3 is a single number. Now, you could put parentheses around it like this, but I just feel like it clutters itself, So this ln5, ln3, they are single individual numbers. They're decimals. I don't know what they are, but they're a number. So in order to keep solving for x and to simplify, I'm going to take that ln3 and distribute it to both of these terms. That's just a single number. Think of it like the number, 2 or 2.5 or 1.3 or something like that. So it's no problem. Let me rewrite here. So I've got 2x ln3. They're just all mushed together. And I got a 7 ln3 is equal to x ln 5 minus 2 ln 5. There we go. Cool. So no problem there. Now what we have to do is get x's on one side, get everything else on the other. This looks crazy, doesn't it? I know, it does, doesn't it? So what I'm going to do is slowly move things over. So I'm going to move my x's over. So I've got a 2x ln 3 minus x ln 5 plus 7 ln 3 is equal to a negative 2 ln 5. I'm going to minus 7 ln 3 onto the other side. You might be wondering, wow, what in the heck is going on here? I know. There's a lot moving parts here. It's a tough problem. It's a tough one. And I know my handwriting's not that perfect either, but, well, as long as you can read it a little bit. That's why I say it out loud a lot of times. Okay, whew, that's so much going on. I want to get x by itself, so I factor that to the front. And I'm left with 2 ln of 3 minus ln of 5 is equal to negative 7 ln 3 minus 2 ln 5. Did you ever have this problem back in Algebra 1414? I don't think so, because this is a pretty big problem. Divide it to the other side as one big set of numbers, and there we go. Yep. This, what I'm typing here, what I'm writing, this is your answer. There you go. This is your answer. Yay! What a feeling of accomplishment. Okay, part B, of course, is going to be the decimal equivalent, negative 18.559. Whenever you type that in, it takes forever to type that into Decimal Scientific, but it will work. So just as a recap, I'm supposed to ln both sides whenever I don't know what else to do, okay? In this particular case, I bring down the powers to the front using that power rule. After that, it's just basic algebra. I say basic, but it's really a lot of complicated stuff going on. I'm moving the ln's in, and then I'm combine like terms, and then I factor out the x's and divide to solve for x. Oof. I actually have that on my notes. It says oof. I'll even write here. Oof. Okay, well, there we go. You just were oofed. So 447. Let's keep going. I got 5 to the power of 2x plus 5 to the x minus 2 is equal to 0. And this is an interesting thing. They want to solve for x, but we've got to understand how to factor this correctly. They want you to factor. What we're going to do is we're going to see this at kind of like x squared plus x minus 2. But I don't want to use x's. I want to use y's. Or u's, or whatever you want to use. Just don't use x's because we already got x's. So why am I doing that? Well, I see that I have this 2 right here, and if I were to rewrite this, it's technically 5 to the x and then squared. So there's this 2 up there. See the 2 right there? Okay, same thing. And then this middle term, there's like a 1 in the front, okay? And then this guy. So this 5 to the x business that we're looking at here, that is your y. If you want to substitute it, it looks kind of like this, and I can then simplify it. Now, I'm assuming that you've seen something maybe like this before. I was just teaching the 1414 class something very similar back in chapter P1, so it is still around. I know it's somewhere in the brain there, but I know it's one of those like dredging it up from the bottom things, okay? So just you're going to have to trust me on this. When you see this kind of problem, the middle term right here is always your y or your u or whatever you want to call it. And then this guy is going to be a square of that. It's like every time. My math lab's very predictable. So you always have a y, you always have a y squared right there. And if you have a number there, that's fine. If you have a number there, it's fine. You just move the numbers down. Okay, so what I want to do now is factor this y squared. I'm going to rewrite it. Y squared plus 1y minus 2 equals 0. I want to factor this. I want to see, hey, what two numbers are going to multiply and add to make this thing work? Well, I think a positive 2 and a negative 1, looking around. And so then I got y is equal to a negative 2, and y is equal to a positive 1. And yay, not really, actually. We need to solve for x. So each one of these actually is saying that it's 5 to the x is equal to negative 2. And I want to solve. And so you can definitely ln both sides, or you can like log base 5 both sides. You could do some friends action. And so we got log base 5 of negative 2 is equal to x. But the problem is here in this particular case, we got log of a negative, and it's not going to work. It just doesn't work. Go and try it on the calculator. It just doesn't work. Okay, so this guy here, same thing. I got log base 5 of 1 is equal to x. Well, if you remember, log of 1 is always equal to 0. Yep, just like that. So, ta-da, x equals 0. That's really the only answer that we have here. Okay. All right, awesome. So, it was wrong. What? I'm so sorry. Part B, the answer is 0. Part A, if I read the instructions correctly, um, oh, I see what's going on. It says use natural logarithms. Let me show you what the answer is. It's totally ridiculous. I actually took a screenshot of this one because it was so wrong. It's so mean. This is your answer for part A. This is so mean. And maybe by the time that you're watching this, this problem might have been fixed, or it might just be removed from the homework entirely. But I'm just going to keep that up there for a second. Why is this so mean? What's going on here? I mean, I know I solved for x, and I probably could have done something else, but look right here for a second. Just look around. Why is that wrong? Why is that so mean? Well, ln of 1 is a 0, right? So the answer is 0 regardless. This is not simplified. This is not simplified. Now, if there were a 2 there, I totally get it. 2. There's a 2 there. Cool. And then we can all talk about it and have fun. There's a 1 there, and a 1 simplifies down to a 0. And 0 is 0. So it's like, why are you even using this as a stepping stone? It makes no sense. So just watch out for these kind of problems, okay? I don't like it as much as you do. Hopefully they fix it. Moving on. 465. So I've got ln of the square root of x plus 4 and then equals 2, and just solve for x. I guess I did write it again. Ah, you got me. So I need to solve for x. Now, this square root technically is a 1/2 power. And so I can move that half power to the front, leaving an x plus 4 right here equals 2. I can still solve. And so what I'm going to do is multiply by 2 on both sides so that these guys cancel. Got a 4. Okay. Now this is where things get a little wonky. How do I cancel an ln? Like, ln cancels an e, right? E and ln, they cancel. So what if I had an ln right here? How do I cancel it? You e both sides, and then they cancel. So you're going to e the ln, and then you're going to have e to the 4. Cancel. So we've got x plus 4 is equal to e to the 4 minus 4 on both sides to move it over. And there we go. E to the 4 minus 4. However silly that looks, that is your answer. Of course, they're going to want an approximate solution stuff, part B things. And I'm just going to write up some decimals there. There you go. Cool. Okay, no, not too bad, not too bad. Keep going. We still got a lot more to do. 421. So I've got now log base 2 of x plus 6 minus log base 2 of x minus 9 is equal to 4. Solve for x. There's definitely a couple ways to do this. I think the easiest one is to see, a minus sign between them. That means that it's going to be division on the inside. See, I'm using those properties of logs to help me. I could rewrite this using friends. So I got 2 up top on the side, that kind of thing. Well, 2 in this fraction, we're good friends, but no longer. You're a fraction. I don't like you. The end. 4 was all by himself. 2 and 4, they're both even. So now they're friends. Well, 2 to the 4th is 16, and it's equal to this fraction here. So now solve for x. I'm going to multiply this to the other side, and so then I got 16x x minus the 9 is equal to x plus 6. Distribute the 16. What is that going to be? 144. I'm looking at my notes. I mean, these are big numbers, man. Oh, come on, plus sign. Look a little bit better. It's close enough. Anyways, I'm going to minus x on both sides. I still feel like I'm writing too tiny today. Well, minus 144 is equal to a 6. I can add the 144. So 15x is equal to 150. There. Divide by the 15. X equals 10. Cool. We still got more. Always got more. 4,477. I've got log of x plus 8 is equal to log of x plus log of 8. Well, it looks like they're the same on both sides, right? With the plus sign and all that? No. Remember, there's a plus sign on the outside. What it makes is a multiply on the inside. Now, I know it's x times 8 versus 8x. It's the same thing, right? Isn't 2 times 3 the same as equal to 3 times 2? So I wanted to make it look pretty, you know. But now that I did log equals log, you can cancel logs. The most common mistake with this problem is that people remember, oh, I need to cancel logs. Totally true. On step 2, don't cancel logs here. You're going to get a mess. You're going to get x plus 8 equals x plus 8. And you're like, I don't know where to go. Exactly. But if you cancel log's second step, after you combine them, everything's fine. I'm going to minus x on both sides. So 8 is equal to 7x. Divide by the 7. So x is equal to 8/7. And there you go. Cool. Okay, I still have one last question. So this is supposed to be an application kind of question. I think they're talking about money invested and all that kind of stuff. There's always a lot of fluffy words going on with these kind of problems. So just break it down to the most important aspects. You have invested $2,550. There's an interest rate, should have just said rate, of 18.3%. Wow, that's like super high. And they're waiting to know, hey, when do you triple the original amount? Not what is the triple amount, you just multiply by 3. They're saying when time equals what, right? Well, you know what's funny about this? This didn't really, you don't need that piece of information in order to find this. But I'm going to use it anyways, but then you'll see it cancel out immediately. The formula we're going to be using is the PERT formula. And I don't know exactly why. They maybe said something like compounded continuously or something like that. But I would say I'm assuming something simple unless they give me a lot more information. And they didn't give me anything else. This is pretty simple, so use a simple formula like PERT, like the PERT formula. So what I'm wanting to result in is 3 times the original amount. But this 2550 is the original amount. R is the 18.3, and then I need to solve for t. Well, these guys cancel immediately, and so you're left with something much easier to work with. Do you see why I said you didn't need that original amount? It's kind of funny, right? So time to triple is always the same for a particular interest rate. Now, if you change your rate, then it's all going to be different, of course. So how do I cancel this E? You ln both sides. Boop. And so we got ln3 is equal to this 0.0. No. There's no 0. I'm so used to putting a 0 in the front because they're always so tiny. Divide by the 183. There's dyslexia talking again. Ugh. Okay, there we go. So t is equal to, do the math. I'm just flipping the page in this particular case. Ln of 3 divided by the 0.183, and I got 6.0033 years. They want a whole number. 6. Wow, you did it. There we go. And actually, that's the last problem I'm doing here. So, cool. That's all I got. Thank you very much. Have a great day.